Okay.
Hello student, I am Dr. S. L. Munde, Assistant Professor Department of Mathematics, Sri RLT College of Science, Akola. Dear student, I think in a previous lecture we have seen some problems on a saddle point. How to find out the saddle point as well as how to identify the given games is strictly determinable or not, fair or unfair. Okay. So in this lecture we will see mixed strategy and then we will see theorem on a mixed strategy. So before going to start theorem, we will see what do you mean by mixed strategy. We have generally seen this definition in basic concept definition. Okay. So mixed strategy is defined as when a player uses a combination of the strategies and each player always kept guessing as to which courses of action is to be selected by the other players at a particular occasion, then this is known as a mixed strategy. Okay, so in this situation we don't know how what the next person will play or will take the actions on uh, our courses action. Okay, so there are types of strategy. So next person will take different types of actions on our actions. Okay, so that types of strategy is called as a mixed strategy. Thus there is a probabilistic situation and objective of the player is to be maximize expected gain or to minimize expected losses. So in this situation there may be the maximize the expected gain possibility of the maximize the expected gain and minimize expected losses to both persons. The expected payoff to a player in a game with an arbitrary payoff matrix which is given as Aij of order m by n of order m cross n is defined as expected of pq equal to summation I equal to 1 to n summation j equal to 1 to n P I A I J Q J equal to P transpose AQ. So here P and Q are the mixed strategy for player A and for player B. Okay, respectively. Okay. So this is the definition of the mixed strategy. Also, we have seen the saddle point definition in previous lecture where the star and plus um, together or intersect that point is called as a saddle point. Okay, so what is the actual definition of the saddle point? A pair of the strategies PQ for which lower V bar equal to upper V bar equal to V is called as a saddle point of E expected of PQ. Okay, so where the star and plus minimax and maximum intersect or equal, so then there exists a saddle point. Okay, so this is the mathematical definition of the saddle point. Now we will see the theorem on mixed strategy. So what is the statement of the theorem? For any 2 by 2 2 by 2 2-person zero sum game without any saddle point having the payoff matrix for a player A. So player A using two strategies A1 A2 and B1 B2 for player B A11 A12 A21 A22. This is the payoff matrix. The optimum mix strategies are for player A is A1 A2 that is P1 P2. Optimum strategy for player B with uh, B1 B2 Q1 Q2, which is determined by P1 divided by P2 equal to A22 minus A21 divided by A11 minus A12 and Q1 Q2 equal to A22 minus A12 A11 minus A21, where P1 plus P2 equal to 1 and Q1 plus Q2 equal to 1. These are the possibilities of the probability of the gain and loss of the player. Okay. Then the value of the game v is given by v equal to a11 a22 minus a21 a12 divided by a11 plus a22 minus a12 plus a21. Okay, so this is the statement of this theorem, mixed strategy theorem. Okay, now we will see the proof of this theorem. What is the proof of? So what is given? We have given mixed strategies for player A. This can be written as strategy for player A is a1 a2 with probability p1 p2, p1 plus p2 equal to 1. Okay, thus if player B moves b1, then net expected gain of A will be, if player B take the action, then the expected of the gain for player A will be E1 of P equal to A11 P1 plus A21 P2. And if B moves B2, then the net expected gain of A will be E2 of P equal to A12 P1 plus A22 P2. Similarly, if the player B plays his mixed strategies, then mixed strategy is given as SP equal to B1 B2 Q1 Q2, where Q1 plus Q2 equal to 1. Okay, then the player B's expected loss will be E1Q, so Q is denoted as a loss. E1 of Q equal to A11 Q1 plus A12 Q2 if player A plays A1 strategies. And expected loss E2 of Q equal to A21 A1 Q1 plus A22 Q2 if player A plays A2. Okay, then the expected gain of player A when makes his moves with the probabilities Q1 and Q2, and which is given as mixed probability of the player A, gain of the player A, and it is given as expected of PQ equal to Q1 in bracket A11 P1 plus A21 P2 plus Q2 A12 P1 plus A12 A21 P2. Okay, so this is the expected gain of the player A. Now suppose that player A would always try to mix his moves. Suppose that the player A always try to use his mixed strategies with such a probabilities, and player A always try to maximize his gain. Then the maximum gain of player A is given as expected of PQ equal to Q1 in bracket A11 P1 plus A21 1 minus P1. Okay, P2 can be written as 1 minus P1 by using the conditions, plus A minus Q1 in bracket, this is Q2, A12 P1 plus A22 1 minus P1, this is P2. P2 we can write 1 minus P1. Okay, so if you multiply and taking the common term, so you will get A11 plus A22 minus A12 plus A21 P1 Q1. So take P1 Q1 common term. Okay, in second bracket A12 minus A22 P1 plus, if you solve this term, take P1 Q1 common term, then P1 common term, then Q1 is common term, and remaining term will be the A22. Okay, so in this way we can write these steps. Now for this, into lambda equal to P1 minus A22 minus A21 divided by lambda, in second bracket Q1 minus A22 minus A12 divided by lambda, plus third term is A11 A22 minus A12 A21 divided by lambda. Okay, so here we have used a lambda for the term that is A11 A22 A11 A22 minus A12 plus A21. So for this term we have used lambda term. Okay, so what is the next? If A chooses P1, suppose that the player A chooses the probability P1, that is A22 minus A21 divided by lambda, and he ensures expected gain of at least A11 A22 minus A12 A21 divided by lambda. So this is the expected gain of the player A. Similarly, if player B choices his uh, losses, he choices Q1 A22 A12 divided by lambda, then B will uh, limit his expected loss at least A11 A22 minus A12 into A21 divided by lambda. So this is the expected loss for the player B if B chooses Q1. Okay. So these are the choices of player A and player B. So player A chooses P1, then player B chooses Q1. If player A chooses P1, then his expected gain at least will be the this term. This is, and if player B chooses the Q1, then the expected losses for the B will be the this. Okay. So here P1 and Q2 will be the choices for the player A and player B. Then the optimal then these choices of P1 and Q1 will these will be the optimal choices of the player A and player B. Okay. Then we can write P1 equal to A22 minus A21 divided by lambda from these choices of player A. And this can be written as A22 minus A21, and where is lambda is A11 plus A22 minus A12 plus A21. Okay. So by using the conditions P1 plus P2, so P2 can be written as 1 minus P1. So 1 minus P1 means 1 minus P1, put these values A22 minus A21 divided by A11 plus A22 minus A12 plus A21. Okay. So take the after solving, so you will get these steps: A11 minus A12 divided by A11 plus A22 minus A12 plus A21. Okay. Similarly, for the choices of player B, the Q1 is given as or found to be A22 minus A12 divided by lambda. So putting the values of lambda, we have considered lambda equal to A11 plus A22 minus A12 plus A21. So putting the values of lambda in this Q1, we get A22 minus A12 divided by A11 plus A22 minus A12 plus A21. Okay. So by using the conditions, that is probability conditions, Q1 plus Q2 equal to 1. So therefore Q2 can be written as 1 minus Q1, and which is given as 1 minus Q1. So 1 minus, take this minus term, taking the cross multiplication and solving. So you will get A11 minus A21 divided by A11 plus A22 minus A12 plus A22. Okay. So in this way we can find out the probabilities for P1, P2, Q1, Q2 for player A, for player B. Okay. Then the value of the game is found to be V equal to A11, A22 minus A12, A21 divided by lambda, that is lambda is A11 plus A22 minus A12 plus A21. Okay. So this is the value of the game. Okay. Therefore, hence we can write from this P1 P2 plus Q1 Q2 P1 divided by P2, that is after putting the values of P1 by 2 P2, we get A2 2 minus A21 divided by A11 minus A12, and Q1 divided by Q2 will be A22 minus A12 Q A11 minus A21. Putting the values of P1 P2 and Q1 Q2, we can find out the ratio of P1 P2 and ratio of Q1 Q2. Then the value of the game V is A11 A22 minus A12 A21 divided by A11 plus A22 minus A12 plus A21. So this is the value of the game. Okay. But actually this theorem is valid for the 2 by 2 payoff matrix. The above formula for P1, P2, Q1, Q2 and V are valid only for 2 by 2 games without saddle point. Okay, so this formula is valid for only 2 by 2 pair of matrix where the given games is without saddle point. Okay, so if the given game is without saddle point, then we can find out the strategies or strategies and the value of the game for the given player A and player B. So we can use this formula. Okay, if the given game is without saddle point and 2 by 2 pair of matrix. So in this way we have seen the proof of this theorem. Okay, so in next lecture we will see some problems on mixed strategies, or we can say that the problems is without saddle point. Okay, if there is a mixed strategy, then we can say that the given problem is a without saddle point. So in next lecture we will see the games without saddle point.